with parametric curves. So we have a couple of situations here. We have a couple of formulas. Let's take a look at this formula here. And you'll recall that by the chain rule, dy dt is, so like this, say you have an intermediate variable x. So you have y as your main variable, intermediate variable x, and then, so it's like, so it's kind of like this, y, x, and t. Now, if you want to take the derivative, if you have this sort of a relationship right here, you want to take the derivative with respect to t of y, then that's dy dx times dx dt. Now, if you want to solve for this one, then this is going to be this one, this dy dt divided by dx dt. Okay, so this formula here comes about immediately from the chain rule. Okay, so the chain rule gives you this formula right here. Okay, so here we have parametric equations. X equals t over 2 plus t, y equals the square root of 2 plus t. And we want to find dy dx. Okay, so what we're going to do then is apply this right here, dy dt over dx dt. Okay, so dy dt, first of all, this is, we can rewrite this as 2 plus t to the 1/2. Maybe that's easier to differentiate that way. And so then the dy dt is going to be, bring a 1/2 one down. This reduces 1/2 minus 1 is negative 1/2, and the derivative inside is just 1, so there we go. So that's just going to be 1. And so the numerator here is going to be 1/2 2 plus t to the negative 1/2. Okay, then let's take a look at this piece here. Okay, so dx dt, we can use the quotient rule. So low d high, that's 2 plus t is the low, d high is 1, so the derivative of t is 1, minus, then the high part is t, times the derivative of the bottom. The derivative of the bottom is just 1. All over the square of what's below, so we get that. Okay, now if you simplify that, what is that? 2 plus t minus t, so that's just going to be 2 over 2 plus t squared. Okay, so the denominator will be 2 over 2 plus t squared. And if you simplify that, let's see, you're going to get 2 plus t to the 3/2 over 4, because 2 minus 1/2 is, so this 2 comes up into the numerator because it's the denominator of the denominator, so this goes up to the numerator. Maybe I should do more steps, okay? Maybe I should do more steps, so as to not be confusing. Okay, so this 2 goes down and joins with that 2, yeah, and we become 4, okay? Okay, so we still have this 2 plus t to the negative 1/2, and then we have this one goes up to the top. And then 2 minus 1/2 is 3/2, so it's 2 plus t to 3/2 all over 4. Okay, and that should be the answer. Any questions about that? Okay, let's do another exercise, number 2. Find the equation of the tangent line to the curve at the point corresponding to the given value of the parameter. Okay, so for the tangent line, the key here was a couple of things. to find that, you need a point and a slope. Okay, now the slope is, let me write this in red instead. Okay. So you need a point and a slope to get the equation of a line, and then you can, from that, you can get the equation. Okay, there's a little bit more work once you have the point and the slope, but you can get it. Okay, so let's go for the point first. And what you do is what I did, we've done before with these. So your value is pi. Okay, so you plug a pi into here for x. So x will be pi cosine pi. Now cosine pi is -1, so that's going to be negative pi. And then y will be pi sine pi. Sine pi of 0 is 0, so that's going to be 0. So your point is going to be negative pi 0. Okay, that's going to be your point. Now for the slope is dy dx. And again, we use the formula. It's dy dt over dx dt. And I guess we can calculate this here. So here's y. dy dt, you're taking the derivative of this with respect to t. So it's the derivative of this, which is 1 times sine t, plus this, t, times the derivative of sine t, which is cosine t. Okay, so that is dy dt. dx dt is, okay, so the derivative of t, which is 1, times cosine t, plus t times the derivative of cosine, which is negative sine t. So we get this. And now, you want to know, you want it when t is equal to pi. So notation, possible notation for this would be that dy dx, where x is pi. No, not x, t is pi. Okay, so in this equation here, you replace all of the t's with pi's. That sounds delicious. I'm hungry now. Okay. Okay, but all the sine pi's are going to be 0, and all of the cosine pi's are -1. So in the numerator we have a pi times -1, and in the denominator we just have a -1, and then both those terms are 0. So the slope is going to be pi. Okay. Okay. So we have a point here, -pi 0, and we have the slope is pi. So we can come up with the equation. One thing I like to do is just write down y equals mx plus b, because they're asking for the equation in that form anyways. You know the slope is pi, so just put a pi in there. Okay, so pi, it gets replaced by pi, and then put this point in here. So here, that means you would set x equal to pi, -pi, and y equal to 0. So 0 here, and -pi there. And b is going to be pi squared. And then plug that b back into here, and there you go. So pi x So y equals pi x plus pi squared. Any questions about that one? Okay, great. Let's go to number 3. Okay, so for number 3, we're supposed to find the first derivative and the second derivative. Let me go back to the first page here. So we're supposed to find the second derivative also. So the second derivative right there. Okay, so the thing about that is the second derivative is equal to the derivative of the first derivative, okay? And so what you do is so the way you can think about this is treat this like y in, if we call this equation star in this first equation here. Okay, so here this is d, so this is basically d, the derivative with respect to x of y. Okay, and that's what that is. That's what dy dx is. Same thing here. This is this is d dx of the first derivative of dy dx. So if you look at this equation right here and replace this y with dy dx, then you get this. And then down here, dx dt, don't need to replace that, so you just get the denominator, okay? And so that gives you the equation for the second derivative. Okay, so that's how that works. We don't have to worry about that every time. We can just take that equation right there. So let's go ahead and do that. So first we have to find the first derivative. So that's dy dt over dx dt. Okay, so the derivative here, so dy dt will be the derivative of this. So it's t times the derivative of the second part. The derivative of e to the negative t is negative e to the negative t. Okay, plus the derivative of this, which is 1 times e to the negative t. Okay, and then dx dt is just e to the t. So you just get that. Now, you can factor out an e to the negative t, and you'll have 1 minus t. And then this e to the negative t goes to the denominator as in positive e to the t. So it's e to the 2t in the denominator. Okay, so that is dy dt. Also, this is also, you could also look at it this way. Instead of taking this one down, you could take this e to the t up, and it'd be e to the negative 2t, like that. AKA, well, also, or whatever. Okay, second derivative. Okay, remember that's the derivative of dy dx. So this is the derivative of this one right here, or this one, divided by dx dt. Okay, so the derivative of this, okay, is going to be the derivative of this first part, which is negative 1, times the second part, plus this first part times the derivative of the second part, which is -2 e to the -2t. And then, of course, this one is just e to the t again. Okay, when the dust settles, you're going to end up with this, 2t minus 3 over e to the 3t. Dang, I can't believe I didn't leave myself more space. But I guess we have enough. Okay, so there's your second derivative right there. Or again, you could write it in this form if you wanted, 2t minus 3 times e to the -3t. Okay, then this part right here, it says find values of t for which the graph is concave up. Okay, find the values of v where it's concave up. Okay, so that's going to happen when the second derivative is greater than 0. Okay, so concave up, that's where the second derivative is greater than 0. So here's the second derivative, we make that greater than 0. Now the denominator is always greater than 0. So this is the same as just having 2t minus 3 being greater than 0. Okay, and then bring the 3 over to the other side, and then divide by 2. So we get that, and we're supposed to put that into interval notation. So 3/2 to infinity would be the answer. Okay, any questions about number 3? Concerns? I wanted to briefly mention something about number 2. So that's kind of interesting, just for you to think about. And that is right here. This describes a curve, right? And wait a minute, no, it doesn't. This describes a curve, and then there's values on the curve. So you have dy dx, you have values for all values of t. Okay, never mind. So this doesn't work out. I was thinking about something else, so never mind about that. We'll just continue on. Oops. Number 4. Find the points on the curve described by this, where the tangent line has slope 1/2. Okay, so they want the points where the tangent line has slope 1/2. Okay, so this means dy dx is equal to 1/2. So what we're going to do is we're going to try to solve that, set that equal to 1/2. So first of all, going to calculate dy dx, which is dy dt divided by dx dt. Just from the chain rule, or from this equation here. Okay, so dy dt, here's y. Derivative of the respect to t is just going to be 3t squared. Here, this is x, dx dt is going to be 6t. And that is going to be t over 2. Because the t's will, this t squared reduces to, this t reduces that t squared to a t. And then 3 over 2 is 1 over 2, so that. And then, so then you're going to set that equal to 1/2. And the only way that that's going to happen is when t equals 1, okay? That's the only solution to this equation, when t equals 1. So, but we need a value of x and a value of y. So I'm going to do this table again. When t is 1, x, you plug a 1 in here for t. That's going to be 6. And then you plug a 1 in here for t for in the y. And that's going to be -3. Okay, so the answer is 6, -3. And that's the only point that's going to work. Even if you go back to here, even if you're making t -1, then you still have a negative down here. So that's still not going to work. Okay, any questions about number 4 or anything previous? Okay, let's go on to number 5. And number 5 is using this formula right here, the arc length, or length of a curve. And instead of having to do, if you have parametric equations, instead of having to deal with 1 plus and something, then it's just the square root of the derivative of the. So in other words, this is your f of t. So x equals f of t, and then this is your g of t. So that's what you plug into the formula. Okay, so your integral, you're going from 0 to 2 pi, 0 to 2 pi, and that gives you the limits of integration. And then what you put inside here is going to be the square root of f prime of t. That's the derivative of this, which we can calculate here. That's 1 minus 2 cosine t. Okay, so what goes in there is going to be this squared plus g prime of t, and we'll do that here. Okay, so derivative of this is 2. Okay, derivative of cosine is negative sine, and derivative of this is 0. Derivative of cosine is negative sine, so that's going to be positive 2 sine t. Okay, so that's what goes there. And then it says use technology to find the length of the curve. Again, when you're doing arc lengths and lengths of curves, unless it's really well thought out, you're typically going to be really hard to integrate. Okay, so let's so what we're going to do is we're going to use our good friend GeoGebra. I guess I could have. I guess I could have. Let me do something here, just for putting it into GeoGebra. Oh, never mind. Okay, let's go ahead and put all this into GeoGebra and see what we get. So I'm going to go to the CAS calculator again. Give myself a lot of room here. And integral. And I'm going to choose this option here. Function, and then variable, start value, end value. Okay, so here I'm on the function part, and it is the square root of, and then in more parentheses, I'm going to put 1 minus 2 cosine of t squared. Use the arrow key to come over, and then plus 2 sine of t squared. That's all square rooted. And then I'm going to come to the variable. I'm going to put t. And for start value, I'm going to go 0. And for end value, I'm going to put 2 times pi. Okay, and they give me some really weird looking thing here, but just press these approximating things. And something's wrong. How's a this is not right. Whoa, something is wrong here, and I can't tell what's wrong. It shouldn't be a negative number. There's no way. This is positive, that's positive, the square root's positive. There's no way this can be negative, and yet the answer is negative. Let me try this. Let me try putting an X in. And I'll just eliminate the that's weird. Okay, that's the correct answer right there. I don't know what went wrong there. I just don't know what went wrong there. So it's 13.364893, so on. So that's the correct answer. So let's go back over and put that in. We'll put that in the other document. So from GeoGebra, now we're supposed to round it off to 4 decimal places. So it's 13.3649. Okay, so it was actually 3.364889, but then we round this 8 up to 9 right there in the last slot. Okay, so that's number 5. Anybody have any questions or comments about number 5? Then let's go on to number 6. Number 6, find the exact length of the curve described by the parametric equations. So again, we're using the same formula. And f prime of t, here's f, so f prime is going to be e to the t minus 1. G prime of t, okay, the derivative of that will be, okay, so the derivative of e to the t over 2 is just e to the t over 2 times the derivative of t over 2, which is 1/2. So that's going to be 2 e to the t over 2. So just plug everything in. It should be straightforward. So 0 to 3 will be the limits of integration from here. And then we have a square root of this squared. Don't forget to square these, otherwise you'll get it wrong. And you'll have to repent and square it in the end anyways. Okay, so you get, so it's that. So this squared plus that squared all under square roots. Okay. If you expand all this out, you get e to the 2t minus 2 e to the t plus 1. And this one squared is going to be 4 e to the t. Okay, so this is another one of those interesting situations where this and this become 2 e to the t. And then that's a perfect square again, so e to the t plus 1 squared. So it's another one of those situations where you had e to the t minus 1 squared, but because this term, adding this term in turns it to e to the t plus 1 squared. But then the square and the square and the square cancel each other out. And sometimes you have to worry about that because this can't be negative, but for values of, well, for any value of t, including values between 0 and 3, this is never negative. This is always positive. So that's fine. And then this is not too bad. Integrate that. It's e to the t. The integral of 1 is just t. And you're evaluating that from 0 to 3. So I plug the 3 in first. So e cubed plus, that's a 3, plus 3 minus e to the 0 plus 0. And e to the 0 is 1, so, and that's 0. So it's e cubed plus 2. That would be the answer. Okay, so e cubed plus 2. Any questions about anything so far? Okay, great. Let's go to the next one. Number 7. Okay, so here we're supposed to do a couple of things. First of all, graph the curve described by the parametric equations. So that's kind of what we did in section 10.1, just graph these curves. Now you're going from 0 to pi. So what we're going to do is we're going to start with 0 and see where that takes us, okay? So x. So you put a 0 in for x, for t in the x in the equation for x. You're going to get 2 e to the 0 cosine 0, and that's just going to be 2. And then for y, you put a 0 in for the equation for y. That's 2 e to the 0 sine 0. That's going to be 0 because sine 0 is 0. Okay, so that gives you the point 2, 0. This is going to be your starting point. It's 2, 0. So you look at 2, 0, and yeah, that's a 2, 0 right there. And that one, so that one can't be it because 2, 0 is not there. And then this is 2, 0 also. And then over here, that one can't be it because it's not even on the graph. Okay, so it could be either this one or this one. Because each of those start at 2, 0. So let's try another point here. And I guess I wish I hadn't. Let me erase this here. That way I can come down and do another point. Now I'm going to choose another value of t to put in here. Okay, I'm just going to write that over here. Starting point 2, 0. So we know that both those start at 2, 0. Okay, now it looks like they both end at the same point. So if I put a pi in here, then I should get this value here, but it's not going to tell me which of these is correct. So I'm going to go with pi over 2. Okay, so the between there, because I can find the cosine and the sine of those pretty easily. Okay, so pi over 2, you put a pi over 2 in here and here. This is going to be 2 e to the pi over 2 cosine pi over 2. The cosine pi over 2 is 0, so that's just all going to be 0. And over here, this is the important one. This is going to be 2 e to the pi over 2 times sine of pi over 2. So sine of pi over 2 is 1, so this is all going to be 2 e to the pi over 2. And this is a positive number, so we're up here, we're right here. Okay. So there's another point that has to be on the graph, and that's right there. And it's not on this one, so you can throw that out. So it's got to be this second graph here. It's got to be this graph there. Okay, now the second part says find the exact length of the curve. And we're going to use the formula for arc length, which you're integrating from 0 to pi, first of all. And then the square root of the derivative of this squared first. So f prime of t, because the derivative of this would be the derivative of this first part, which is e to the t, times the second part. So 2 e to the t cosine t, plus this first part, which is 2 e to the t, times the derivative of that, which is negative sine t. So that's going to be minus 2 e to the t sine t. Okay, and that's all going to be squared here. Oh dear, we're running out of space. Okay, now the second part is going to be, let me do this in a different color. G prime of t, that's the derivative of all that. So that's 2 e to the t sine t plus 2 e to the t cosine t. Okay, so this is the derivative of e to the t times sine t, and then this one is 2 e to the t times the derivative of sine t, which is cosine t. Okay, so we have 2 e to the t sine t plus 2 e to the t cosine t, and that's all squared as well. So what we can do is go ahead and square everything out. So squaring this one is going to give you 4 e to the 2t cosine, what the? Cosine squared of t. Okay, plus the product of this times 2, so that would be 2 times 2, that's 4, times 2 is 8, so that's minus 8 e to the, so it's the e to the t times e to the t is e to the 2t, and then we have cosine t sine t, and then we have this squared, which is going to be 4 e to the 2t sine squared t. Okay, and then we're going to square these ones right here. And this is going to give you the first term squared, which is 4 e to the 2t sine squared t. And then this times this and doubled it is going to be 8 e to the 2t sine t cosine t. And then this one squared is going to be 4 e to the 2t cosine squared t. Okay, now a nice thing happens, which is that and that are going to cancel. Yay. Okay, now another thing that happens let's see, I don't want to run out of space. I'm going to do this. Okay, another thing that happens is this. So if you take this and this, or I guess I could take that and that, doesn't matter. If I take that and that, then that's 4 e to the 2t times cosine. And I guess I could just take that. I guess likewise I could take that and that. I mean, how do I explain this? I guess, or maybe you guys see it already. I think maybe you guys see it. Cosine squared plus sine squared is 1, right? So I'm using that. So so this and this together is 4 e to the 2t. This is another 4 e to the 2t. And so in the end, I'm just going to have 8 e to the 2t. And that's it. Okay, so using that identity there, all of this reduces to 8 e to the 2t. Now, when I apply the square root to it, I'm going to get the square root of 8, which is 2 root 2 times the square root of e to the 2t, which is e to the t. Just like that. And then I find antiderivative is just 2 root 2 e to the t. That's evaluated from 0 to pi. So that's 2 root 2 e to the pi minus 2 root 2 e to the 0, which is 2 root 2 times e to the pi minus e to the 0 is 1, so that's just a 1.